Hi guys, so today in this video I'm going to explain you the binary search algorithm, its implementation in iterative method. So in two ways we can implement this. One is the recursive method that I'll provide in next video, and this is an iterative method wherein you create a function and you loop through the array, and that's how this works. So what is binary search algorithm? It's an algorithm used for a sorted search space. Okay, so the key point that you have to remember here is the search space that you are going to use, either it be an array or a vector, whatever it is, it should be sorted. And this is the key point that you always have to remember, okay? So the real life example of this would be a dictionary, wherein suppose we have a word cat and we need to find that. So how would you find that? You don't go through each and every word like from the first, starting from here, right? So in the same way, binary search, what does it does is it divides your search space into two, and then you're gonna find the element. So let's just straight away get to coding. And meanwhile, I will explain you, and in detail, I'll explain you at the last. Okay. So let's get started. So first, we have to include the basic libraries, right? And then we have to use the namespace, right? The standard namespace for cout and cin functionalities. So using the namespace, oops, right? And now let's get started with our function. So the function that we're going to use is binary search, right? So let's create that. Here it takes integer and binary search. And what does it take? It takes the parameters as a vector, so vector, which should be integers, right? And let's declare it as nums. So here ampersand is a very important, as it takes a reference that you pass it as an argument and it takes in, right? And then we need a target. So what this target is, like suppose there is a vector which contains 3, 4, 5 sets, and I want to find my target is 3. So here I want to find 3, and so based on the target we find the index. I mean, we return back the index. Okay, so at first let's just take in the size of the nums. We have to know the size of the nums vector, right? So let's say it's n. We'll store it in the variable n, which is equal to nums dot size. All right, and now we need two pointers. One is low, one is high. I'll explain in detail, don't worry. Say, and low should point to the first index of the vector, right? So low should be 0, and then we need a high pointer which points to the last element, that is, I mean the last index, and that will be n minus 1, right? Now we need to do something continuously. So for doing something continuously, what we use? Obviously we use a looping strategy, right? And here let's use the while loop. And while low should always be less than or equal to high, and the moment high passes low, that is like during the index, like searching, when the moment high passes low or high is greater than low, when high becomes greater than low, at that time you can say there is no more search space left, right? So while low is less than or equal to high, we're going to do something, and in between this loop we are going to do some steps wherein we can find the index of the target. Okay, so at first we need another pointer which is mid, and this mid points the element, right? So let's say the mid will be the exact half, right? So how will we get the half of a vector or an array? We'll just divide low plus high by 2, right? And now what we're going to do is we're going to keep a condition, like we're going to tell the search algorithm that if now we have got the mid value, right? And if that mid value, or if the element that stays at the mid index, that is if nums of mid is equal to the target which we need to find, if that is true, then you got the answer, right? So you just return the mid. All right. Else if, what will be the other condition? Else if the target is greater than the mid value which you found, okay? Sorry, the nums of mid. Oops. If that is greater, then you have to eliminate all the left search space. And how are you going to do that? You're going to increment the low to mid plus 1. That is low equal to mid plus 1. Else, if target is not greater and target is less than the array of mid, the mid value, then we have to decrement the high. We have to decrement the high pointer to mid minus 1 value, and the search space becomes only the left area, right? So high will be mid minus 1. All right. And then if none of this works, if none of this condition is there, that is, you are not going to find the element, right? And then you just return minus 1. That's it. So this is the basic functionality or the algorithm implementation of binary search. Now we have to pass in all the vector, the target, everything. So we'll call the main. Okay. And then you have to pass a vector, right? So vector will be an integer. Let's name it A, which will be containing elements, say 4, 5, 6, 17, 19, etc. It's your choice. And we need a target, right? So it will be an integer value. And let's say I need to find where the index of 17 is. Okay. Now we have to call a function, right? In order to find where the 17 is in this vector. So on calling this function, let's store it in a variable called index, because that's what the function is basically returning, right? So index equal to binary search, the function which we created, and then we're going to pass in the vector as well as the target, right? So the vector is A and the target is target, right? Now, what is the condition? If the function returns minus 1, that is this, if the function returns minus 1, then let's write that. If int equal to minus 1, then what we should say that obviously the target is not present, right? And let's just give a line. Okay. Else, obviously the target lies at the int, like the value which the binary search returns, right? So else we just print the target is present at the index. Let's just give it a space. Okay. And right. So And then finally we have to return this. Okay, let's just run this. Yep, here we go. The target is present at the index 3, right? So here we asked to find our target. We gave the target as 17 and we got the index at 3. That is 0 is 4, 5 is 1, 6 is 2, and 17 is 3, right? So this is how we implement binary search using the iterative method. So let's just go through this, right? So as I said, binary search works only for the sorted array. Sorted search space, not only array. My bad. So yeah, and here in this, you have to pass in the vector as well as the target, right? So let's say we have an array like 4, 5, 6, 79. Here at first low will be at 4 and then 0 and then high will be here, right? And on dividing we get a mid value, and that mid value, if that is equal to the target, right? If that is equal, then we have to return, like if the target and that value is equal, then we return that. And if it is not, we have to check whether the target is greater than numbers of mid. Then if it is greater, then what we can do is we can just say low is here, then we can just eliminate this, right? And it will go over here. So the search space becomes less, right? And that's how the whole algorithm works. And then if it is greater, then we have to, if it is lesser, then we have to decrement the high so that all the right search space will get eliminated. And that's how this entire algorithm works. So in order to learn this, the important thing that you have to keep in mind is it's not just about going through the video and just copying the code. Just take the paper, write down an array like whatever you wish, like a equal to some numbers, store some values, and then take low, high, and or do all this stuff. Then you'll get the answer. That's it. Thank you.